Welcome. In this video, we'll explore two essential patterns for creating objects in JavaScript: factory functions and constructor functions. If you've ever wondered how to efficiently generate multiple similar objects, or what the differences are between these two approaches, you're in the right place. We'll start by understanding why object creation is so important in JavaScript, then dive into each method, compare them, and see practical examples. By the end, you'll have a clear grasp of when and why to use each pattern. Let's get started with the basics of object creation. Factory function is simply a function that returns a new object each time it's called. You don't need to use the class keyword, constructors, or even the new keyword. This approach is straightforward and flexible, making it a favorite for many developers. Factory functions are especially useful when you want to create multiple objects with similar properties or methods, but don't want to deal with the complexities of classes or inheritance. Let's see how you can use a factory function to create objects easily and efficiently. Before diving deeper, let's quickly review how you can create objects in JavaScript without factory functions. You can use object literals like const obj equals name, Faris, age, 29, or create an empty object and assign properties one by one. These methods are great for single objects, but if you need many similar objects, repeating code becomes a hassle. That's where factory functions shine, helping you avoid repetitive code and making your programs more maintainable. If you want to create many similar objects, factory functions save you from writing the same code over and over. Instead of copying and pasting object structures, you can call a factory function with different arguments to generate new objects. This not only saves time but also reduces errors and makes your code easier to update. Plus, factory functions let you encapsulate logic, so if you need to change how objects are created, you only update the function. Let's look at a simple factory function in action. Imagine you want to create people objects with a name and a talk method. The factory function takes a name as an argument and returns an object with a talk method that uses that name. For example, calling humanCreateFactory Faris gives you an object where talk returns, "Hello, I am Faris." You can create as many people as you like, each with their own name and talk method, just by calling the function with different names. As your objects get more complex, factory functions become even more valuable. Imagine each person object needs several methods and properties. Instead of manually adding them for every object, you define them once in the factory function. This keeps your code organized and easy to maintain. If you need to update how objects are created, you only change the factory function, and all new objects will use the updated logic. One of the benefits of using factory functions is easier error handling. Since all object creation logic is in one place, if something goes wrong, you only need to check the factory function. This makes debugging simpler, especially as your codebase grows. You won't have to search through dozens of lines to find where an object was created incorrectly. Now let's talk about constructor functions. In JavaScript, a constructor function is used to create objects, often in an object-oriented programming style. When you use the new keyword with a constructor function, JavaScript automatically creates a new object, sets up its prototype, and binds this to the new object. Constructor functions are a classic way to generate multiple objects with similar properties and methods, especially before E6 classes became popular. Constructor function looks like a regular function, but by convention its name starts with a capital letter. Inside, you use this to assign properties and methods. When you call the function with new, JavaScript creates a new object, binds this to it, and returns it. For example, function person name, this name equals name, creates a new person object with a name property when called with new person Faris. Instantiation is the process of creating a new instance of an object. When you use the new keyword with a constructor function, JavaScript does a few things behind the scenes. It creates a new empty object, sets the prototype, binds this, and returns the object. This process is automatic, so you don't have to manually return the object or set up inheritance. It's a powerful way to create many similar objects efficiently. Let's see a constructor function in action. Suppose you have function person name, this name equals name. When you call new person Faris, JavaScript creates a new object with the name property set to Faris. You can create as many people as you want, each with their own name, by calling the constructor with different arguments. This is called object instantiation, and it's a core concept in object-oriented JavaScript. One of the key features of constructor functions is the automatic creation and binding of this. When you call a constructor with new, JavaScript creates a new object and binds this to it. You don't need to return the object manually. JavaScript does it for you. This makes constructor functions convenient for creating objects with shared structure and behavior. You can add methods directly inside the constructor function by assigning them to this. For example, the stock equals function, return, "Hello, I am this name dollars," Each object created with the constructor will have its own copy of the method. This is simple, but if you create many objects, each will have its own version of the method, which can use more memory. Both factory and constructor functions help you create objects efficiently, but they have some differences. Factory functions return objects directly, while constructor functions use the new keyword and this. Factory functions are more flexible and don't require special syntax, but constructor functions integrate better with JavaScript's prototype system. Let's look at some key differences and see which approach fits different scenarios. With factory functions, you call the function and get an object back. With constructor functions, you use the new keyword and JavaScript handles object creation for you. Factory functions don't use this or new, making them easier to understand for beginners. Constructor functions require you to remember to use new, or else this might not work as expected. Factory functions create a new copy of each method for every object, which can use more memory if you create many objects. Constructor functions can also do this if you assign methods inside the constructor. However, if you use prototypes with constructor functions, all objects share the same method, saving memory. This is a key advantage of constructor functions when working with many objects. With factory functions, you can easily change methods or properties on individual objects without affecting others. For example, you can override the talk method for one person, and it won't change for others. This flexibility is useful when you need unique behavior for specific objects. Constructor functions can do this too, but it's more common with factories. One of the strengths of constructor functions is easy prototype inheritance. You can add methods to the constructor's prototype, and all objects created with that constructor will share those methods. This saves memory and makes it easy to update behavior for all objects at once. For example, person prototype talk equals function. Lets every person object use the same talk method. Factory functions can also use prototypes by creating objects with object create. This lets you share methods across objects, just like with constructors. For example, you can define a prototype object with shared methods, then use object create to make new objects that inherit from it. This approach combines the simplicity of factories with the efficiency of prototypes. If you want to update a method for all objects, using prototypes is the way to go. With constructor functions, you add or update methods on the prototype, and all objects automatically use the new version. With factory functions, you can achieve the same by using object create and a shared prototype. This makes it easy to maintain and update your code as your application grows. A common mistake is adding methods directly to object prototype. While this makes the method available to all objects, it can cause unexpected behavior and bugs since every object, including built-in ones, will have the new method. It's better to use prototypes specific to your objects, not the global object prototype. Instead of modifying object prototype, define your own prototype object with shared methods. Then, use object create to make new objects that inherit from this prototype. This keeps your code safe and organized, and only your intended objects get the shared methods. It's a best practice for both factory and constructor patterns. Let's see how to use a prototype with a factory function. First, define a prototype object with shared methods, like talk. Then, use object create to make new objects that inherit from this prototype and assign properties using descriptors. This way, all your objects share the same methods, saving memory and making updates easy. Constructor functions make it easy to use prototypes. Just add methods to the constructor's prototype, and all objects created with new will share those methods. For example, person prototype talk equals function. Gives every person object access to the talk method. This is a classic pattern in JavaScript for efficient object creation. Inheritance lets you create new objects that reuse the behavior of existing ones. Both factory and constructor functions can use prototypes for inheritance. This means you can define common methods once and have all your objects use them, making your code more efficient and easier to maintain. Factory functions are great when you need flexibility, want to avoid the new keyword, or need to create objects with private data. They're also useful when you want to easily customize individual objects. If you're working with functional programming or want to avoid some of the quirks of this, factory functions are a solid choice. Constructor functions are ideal when you want to use JavaScript's prototype system for efficient memory use and easy inheritance. They're also a good fit if you're building complex object hierarchies or using frameworks that expect constructors. If you're comfortable with this and new, constructor functions can make your code more organized and efficient. One common mistake with constructor functions is forgetting to use the new keyword. If you call a constructor without new, this won't refer to a new object, and you might accidentally modify the global object. Factory functions don't have this problem since they always return a new object. Factory functions can easily create objects with private data by using closures. You can define variables inside the factory that aren't accessible from outside, but can be used by methods. This is a powerful way to encapsulate data and protect it from being changed accidentally. Constructor functions don't provide built-in support for private data. All properties assigned to this are public. If you need private data, you'll need to use other patterns like weak maps or symbols, but these are more complex. Factory functions make private data much easier to manage. Factory functions use plain functions and object literals, making them easy to read and write. There's no special syntax or keywords to remember, which is great for beginners or when you want to keep your code simple. This simplicity is one reason why factory functions are popular in modern JavaScript. With the introduction of E6, JavaScript added the class syntax, which is essentially syntactic sugar over constructor functions and prototypes. Classes make it easier to define constructors and methods, but under the hood, they work just like constructor functions. If you're comfortable with constructors, learning classes is a natural next step. Factory functions remain popular in modern JavaScript, especially in functional programming and frameworks like React. They offer flexibility, easy customization, and support for private data. Many libraries and tools use factory functions to create components, services, or utilities. Constructor functions are a staple of object-oriented programming in JavaScript. They make it easy to create complex object hierarchies, use inheritance, and organize code in a structured way. If you're building large applications or working with OOP, constructor functions are a valuable tool. To recap, factory functions and constructor functions both help you create objects, but they have different strengths. Factories are simple, flexible, and support private data, while constructors integrate with prototypes and support inheritance efficiently. Choose the pattern that fits your needs and coding style. Let's walk through a practical example using a factory function. We'll create a function that returns a person object with a name and a talk method. You'll see how easy it is to generate multiple people with different names, and how you can customize each object as needed. This pattern is great for simple, flexible object creation. Now let's see a constructor function in action. We'll define a person constructor, use new to create people, and add methods to the prototype. This approach is efficient for creating many objects that share the same behavior, and it's easy to update methods for all objects at once. If you want to change a method for just one object created by a factory, you can simply override it. For example, person1talk equals function. Changes the talk method only for person1. Other objects remain unchanged. This is useful for special cases or unique behavior. With constructor functions, you can update a method for all objects by changing the prototype. For example, person_prototype_talk equals function. Updates the talk method for every person object. This is efficient and ensures consistency across your objects. Choosing between factory and constructor functions depends on your needs. If you want simplicity, flexibility, and private data, go with factories. If you need efficient inheritance and are comfortable with prototypes, constructors are a great choice. There's no one-size-fits-all answer. Pick the pattern that fits your project and team best. Here's a quick summary. Factory functions are simple, flexible, and support private data, but can use more memory if not using prototypes. Constructor functions integrate with prototypes, support inheritance, and are efficient for many objects, but require the new keyword and can be less flexible. Use this table as a quick reference when deciding which pattern to use. If you want to dive deeper, check out resources like JavaScript Factory Functions with E6+, articles on object-oriented programming in JavaScript, and guides on instantiation and inheritance. These will help you master object creation patterns and write better JavaScript code. This video is based on the article by Faris, a full-stack developer passionate about sharing knowledge. The goal is to help you understand the core concepts of object creation in JavaScript and empower you to write cleaner, more efficient code. Keep exploring and experimenting with both patterns to find what works best for you. Understanding factory and constructor functions gives you powerful tools for building scalable and maintainable JavaScript applications. Whether you prefer the simplicity of factories or the efficiency of constructors, mastering both will make you a more versatile developer. Thanks for watching, and happy coding. Ready to put your knowledge into practice? Try creating your own factory and constructor functions for different scenarios. Experiment with prototypes, inheritance, and private data. The more you practice, the more comfortable you'll become with these essential JavaScript patterns. Good luck!